I'm Professor Pi. Welcome to my daily mathematical adventures. Hey, don't forget me. I'm Cowboy Rufus. I'm your favorite student. Okay, this is either video number 3 or part number 3 of a very long video, but right now I'm going to talk about the phase shift. Phase shift is how we're going to move our graph right and left. And it says I can graph the phase shift of sine and cosine on the TI-83 calculator. Now, once again, you can do it the way I did it millions of years ago in high school. There are 16 X, Y points on the unit circle you can get, and you can get others if you need them. But every 30 or every 45, every 60 degrees, there is an X, there's a Y. Remember, cosine is X, sine is Y. And then you'd make a T graph that looks something like that. We're going to skip that and go on. We're graphing trig functions on the TI-83, and to simplify this, I'm going to have you go to mode in radians and hit zoom and go to 7-number trig. Now, you could go to window and customize your window to change every 5 degrees or every pi divided by 6 radians. The standard trig function will be good enough for our purposes. We will use the TI-83 later in the year to get some very specific trig readings. All right, you're in mode in radians. How do you know that? You can check it by hitting sine of 30. If the sine of 30 still comes up 1/2, then you are not. If you're still getting the sine of 30, then you're not in radians, you're in degrees. So let's go graph some of these. There's the transformation once again. We've talked about the amplitude. It's there. It's A. The period is K. This is the third one. So now we're going to add it with X in parentheses. And all that's going to do, it's going to shift our graph over. So we're going to go to the graphing calculator. We're going to do some graphs, and then we're going to phase shift. It will take our graph and move it up and down the x-axis. All right, first thing I want you to graph is the basic one again. Let's do cosine. Cosine of x, y equal to cosine of x. I get the same graph. Y equals on your calculator, y equals button, cosine, put the x into parentheses. Now, let's also graph the next one, put in sine. Y equal sine of x. Notice that they're always 90 degrees apart. At 90 degrees, which is pi is 180, right? So 90 degrees would be right here. At 90 degrees, the sine of 90 is 0. That's the blue one, right? No, it's not right? All right, get it right for me. He's right. The sine of 90 is 1, and the cosine of 90 would be 0. The sine of 0 is 0, the cosine is 1. Now, what happens if I move the sine over 90 degrees? X plus 90. X plus 90, if I can type it in there, x plus 90. Now, is that the same as that graph? It is the same as that graph. My calculator is just showing me that they're a little bit off. Why are they a little bit off? To show me that it's basically the same line. But what happens? So if I take sine and move it 90 degrees, or we could move it minus 90 degrees. Now I get that loop sensation. What did I do to the green one? Let's try it again. I wanted to show you that if you graph cosine and sine at the same time, you're going to have one on top of another. So let's just use cosine. Now, the next equation, we're going to put something with the cosine. Let's start by just putting with the cosine y equals cosine plus 15 degrees. Cosine x, the x has to be in the parentheses. If it's not in the parentheses, you get what we're going to talk about in the fourth one, which is the vertical shift. What did I do? Hey, are you in radians or are you in degrees? What did I tell you? Put your calculator in. So everybody in the room's in radians, and I'm up here talking about degrees. You can't double mix this thing. Absolutely right. You can't mix the radians and degrees. We can either plot these points in radians, we can plot them in degrees. Your calculator was set for radians, so I shouldn't be adding 30 degrees. Now I'm adding 30 degrees in radians, pi divided by 6. What did I do? I took the regular sine curve here and my new function in red. All I did was move it over 30 degrees. I moved it over 30 degrees. What happens if I move it over 90 degrees? It now looks exactly like the sine would. This is 1. Look at the red one. Sine is 0. Cosine is 0. When I move it over 90 degrees, it's going to look exactly like the sine and cosine. Cosine looks like sine if you shift it 90 degrees. What if I shift it 45 degrees, which is pi divided by 4, of course? All I did was move my graph over 45 degrees. The humps moved over 45 degrees. The humps didn't change. We haven't changed amplitude. Humps are still one high and one low. We didn't change the period from one up hump and one down hump, one up hump, one down hump. Our period is still 360. All we changed was the vertical shift. Could I shift it way out? Yeah, get a bigger number. Let's get rid of what happens when I shift it out to pi. I've got this pretty little chain. What I actually do, I move this hump from here over to here. I moved it from 0 to pi 1. Could we make very much of a tiny little shift? We could make a tiny little phase shift, which is what we've done now, but it's hard to tell that I only moved this thing a few degrees. Pi is 180 divided by 360 is 5 degrees. That's all I moved it. Our phase did work, but it's very hard to tell on your graphs. So let's go back and put pi divided by 6. And on your graph, you should see that you moved it sideways 30. Did you move it sideways back or front? Hey, it went from the green to the red. We moved it back. What else do we make this a minus sign? Now I moved it forward, right? I've now moved it forward from the original green to the new red. I moved it forward 30 degrees. So it does matter whether this sign is positive or negative. And that's what you need to know about the shift phase. Wait for the fourth video, then we'll try and combine them all. Okay, this is the last of a series of 4 that we're going to talk about transformations of sine of x and cosine of x. This is called vertical shift. This is going to allow us to raise our graph. We're going to slide it up, we're going to slide it down. There is a way to do this with points. Many centuries ago when I was in high school, we did it with points. We plot the x, we plot the y, we plot the x, we plot the y. There are 16 alone around the unit circle that we have memorized. We can use those x and y points. We can make us a t-graph. We can get some graph paper and we can graph these points. We're not going to do that. We're going to pick up the graphing calculators in a minute, and I'm going to show you what the transformation does. Now, we've already talked about A. A is amplitude. It goes in front of sine. Then we talked about K. K changes the period. It goes in front of X. Then we talked about the phase shift. If you put something in parentheses and add it or subtract it with X, it shifts our graph sideways. Now we're talking about vertical shift. We're going to take the same graph we have. We're not going to change the period. We're not going to change the amplitude. We're going to move it up. We're going to move it down on our y-axis. The vertical shift does not need the constant inside. It needs to be outside the parentheses. The plus has to be after the X. And if you're using parentheses, it needs to be outside the parentheses. Now let's go to the graphing calculator. For simple, we're going to do it very simply. We're going to mode radians and we're going to zoom trig. You know how to do that. This is the 4th time we've done that in class. Go ahead and do that. Now let's go to the graphing calculator. I'm going to put in sine for fun. We could do cosine, but we could do both of them. Y equal cosine x. Looks a lot like that. How do we know it's cosine? What's the cosine of 0? 1. What's the cosine of 90? 0. So it checks. I always check that, but of course the graphing calculator is going to be right. But I always check it just out of habit. Now, we're going to move our graph up. What do you think we need to do to move the graph up? Get another one. And let's go y equal, we'll move it straight up. Y equals cosine. Now, if we say 4x, then we're actually changing the period. If we say x plus 5 in parentheses, then we're actually going to shift it. So we don't want parentheses. All we want is a plus sign and a 3. And I've got to make this a plus sign because sometimes I don't type so well when I'm talking to you. Sometimes I don't type so well anytime. Y equal cosine. I got to type it right. Cosine x plus 3. What'd we do? Everywhere there's a 1, we went up to 3. But we didn't change the amplitude. Everything that's now 2 was at -1. So all we did was move our graph up 3. What are we going to do to move our graph down 3? Somebody said, okay. He says, put in a -3. There we go. We've moved it down 3. We haven't changed the amplitude. We haven't changed the period. And we haven't changed the phase shift. Now, since this is the 4th one, I need to tell you that not everybody does this in 4 different videos. I thought it would be best for our class if I did it in 4 videos. So on one video, I only changed amplitude. And in another video, I only changed period. Then I changed phase shift. You can put all 4 in one equation if you want. So let's get rid of this equation. And let's start with the next equation. And I'm going to try and show you what each one is And I'm going to do it with the simplest numbers around. Copy mine. Y equals 3 cosine x plus pi divided by 4, which would be a 90-degree shift, right? No, you're right. Pi divided by 4 is 45. It's not 90. I thought I'd trick you there. You stop nodding your head and start shaking your head. No, I got it. Y equals 3 cosine. And then let's raise it, I don't know. Let's raise it 2 plus 2. Here's the original cosine. Did we change the period? Yes, we did. One up hump, one down hump. Did we change the phase shift? Did we raise it up to 2? Did we put all of them in together? Yeah, we did. Can I take them out one at a time? Yes, I can. Now we've changed the amplitude, we've changed the period. Wait a minute, did we change the period? What's out here? Let's change the period. Now I've changed the period, the amplitude, and the phase. Can I get rid of one of these at a time? Yes, I can. Let's get rid of the phase. Now I have changed the period and the amplitude. I've made the waves higher and I've made them more compressed. Can I get rid of that again? Yes, I can. We can get rid of the amplitude and only change the period, or we could get rid of the period and put the amplitude back in. But I need you to know that sometimes we're going to change 4 of these. You need to know the original concept. The original concept, as I have it drawn here, is amplitude is A, and it gets in front of sine or cosine. K goes in front of X. That would change the period. What's the period? The normal period is 2 pi. If I make K 5, we're going to take 2K, or 180, and divide it by 5. And 180 divided by 5, we would change the period. The humps would happen in 36 degrees, not 180 degrees. What? He says, that's not what I taught you the second day. He's right. We don't divide. Now we go back to the originals that I showed you. A is amplitude. We can change it. That changes the height and the depth of the waves. It goes in front of the sine or cosine. K changes the period. The period is normally 360 degrees or 2 pi. If we make K 4, we divide 360 by 4 and we get 90. The period would be, the waves would be more compressed. This is the vertical shift. We put X in with parentheses with a C, and we can move our line vertically. All right, we do all 4 together. We can go back and look at the original drawing that I have for you. A is the amplitude, and it changes the height and depth of the wave. K is the period. The normal period is 2 pi, but if you change K to 5, you would have 2 pi divided by 5, or you would be changing the humps, one up hump, one down hump, 360 divided by 5. I think that's 72 degrees. Then you can have the phase shift. C is phase shift. You add it to X in the parentheses, and that will shift your graph sideways. Then we have the vertical shift, which is D. You put that outside the parentheses and add it to X, and it moves your graph up or down vertically, up and down the y-axis. Sometimes you'll see two of these, sometimes you'll see three of these. Seldom will you see all four at once, but you need to be able to recognize each of them and define each of them. And that's what you need to know about the transformations of sine and cosine. Thanks for watching another Professor Pi video. Yeah, y'all come back tomorrow. Cowboy Rufus and Professor Pi will teach you something new.